Well, hello and welcome once again to the Waters and Stanton video channel. It's a lovely sunny day, 26 degrees centigrade, and I'm located near Sizewell on the east coast of Suffolk. The actual location is a place called Leiston. Now Leiston is inland from Sizewell by about three miles or so. And I'm actually on the site of what was originally RAF Leiston. During the war, RAF Leiston was created. They started construction in 1942, finished in 1943, and as soon as it was finished, the airfield was occupied by the American Air Force, and they remained present at the airfield for a number of years. I think in the late 1940s, it was put into mothballs, care and maintenance, I think they call it. And then in 1955, it was completely closed down and the land sold off. And I'm actually on a campsite on what was part of the airfield. Obviously not the airfield now. Although interestingly enough, if you look at Google Earth, you can see traces of the runway because a lot of it is now farmland, and as happens when they pull up runways and taxiways and so forth, you can still see the shadows there or the traces of it because there's different soil colouring and so forth. So you can actually see Leiston Airfield in terms of where the runways were, but that's about all you can identify. Now it's farmland. Anyway, not the reason I'm here, but one of the advantages of being here is it allows me to test out an antenna which I've been working on. Now, as you probably know, I've done a lot of work on end-fed half-wave. About 6 months ago I did a video covering end-fed half-waves, and one of the things I was highlighting was the fact that if you're out portable and you put up a length of wire which was 10 metres long in a vertical fashion, that would be a great vertical antenna for 20-metre operation, because I think most hams can actually put up a fiberglass mast that's about 10 metres long, certainly out portable, and that 10-metre long length of fiberglass will support a wire of approximately 10 metres long, and that will give you good performance on 20 metres as an end-fed dipole. In fact, probably about 25 years ago now, it was the first time I used an end-fed half-wave on 20 metres, and at the time I used an MFJ antenna tuner at the base. I was operating on the edge of a sea lock in the west coast of Scotland, but I got some remarkable results. I was working across the pond regularly to the USA, and when I subsequently modelled the antenna, I found that it actually gave about 2 degrees lower angle of radiation than the quarter wave. And I've never forgotten that, you know, that a half wave vertical gives this slight edge on a quarter wave vertical. And the other thing, of course, is that the half wave vertical doesn't require much in the way of radials, doesn't really require a radial field at all. And the point of maximum radiation is up in the air. It's 5 metres up the wire, which means to say that it sees more sky than your quarter wave vertical would do. And it works very well, and well, I knew it would work, and it works well. One or two things I will say about that in a moment, but basically it's a great antenna for 20 metres. Now, I also pointed out in my video that it will work on 10 metres because the end-fed half-wave works on harmonics, so if it works on 20 metres, it will also work on 10 metres. The downside when you use it as a vertical antenna is that the angle of radiation is significantly higher, which means to say that it's not quite so good for DX. You could argue that it's okay for sporadic E, and I mean it will work on 10 metres, but you'll lose some dB in the low angle radiation. 10 metres at the moment is a bit hit and miss. We've gone through the sporadic E season now, so 10 metres is not likely to be quite so lively as it was, and I think we can say with a measure of assurance that will be a year or so before 10 metres starts to become a more interesting band other than sporadic E. So whilst the 20 metre and 10 metre antenna is possible and works, for many 10 metres is not the band of choice. If you have an antenna that works on 20 metres, you probably wouldn't then say, well, what I'd love it to do is to work on 10 metres, wouldn't that be great? Well, of course we know it does, but it wouldn't be great because a lot of people have got bands other than 10 metres they want to switch to. I have been working recently on an antenna which covers 20 metres and 17 metres. Now, there's two advantages there. 17 metres is a very good band at the moment. It's regularly open and you can get some nice DX, particularly in the mid-afternoons. It seems to spring to life, and you can get some good DX running quite reasonable power. Now, if the antenna covers 20 metres and 17 metres, you've got two very good bands. You've got a 20 metre band which is open, well, it's all day and a good part of the night these days, and 17 metres which springs into action particularly during the afternoon. And also importantly, that if you go on at the weekend and there's a contest on, there's no contest operation on the 17 metres. So if, as often happens, you go on at the weekend and you think, oh, there's another contest on, you may or may not like contests. If you don't like contests, you go on 17 metres and there's no contest activity at all. So the idea of a 20 metre and a 17 metre antenna is a great idea.
Sam, spell Sugar Alpha Mexico. Sugar Alpha Mexico. Sam is the handle, and KTH is about 250 kilometers east of Sapporo City. Back to you. Japan Hotel 8, Radio Bravo Yankee. Over.
Now here's something that a lot of people probably don't realise until they try it out, and that is when you use an end-fed half wave, the matching transformer, the 49:1 or whatever ratio you decide to use, the 49:1 matching transformer loads the end-fed half wave, and it actually lowers the frequency. So if you try to model a vertical, 20 metre vertical, you will find that the length that the modelling comes up with is not the length that you actually finally need to use, because the transformer loads that half wave and reduces the resonant frequency. Now I can explain how this happens very easily. If you have ever played about with a vertical antenna, an HF vertical antenna, say for, I don't know, 20 metres, 15 metres, 40 metres, what doesn't matter what it is. If you've ever played around with a mobile antenna and touch the top of the antenna, as you approach your hand and as you touch it, the signals all but disappear. There's about a 20-25 dB reduction. That end of that antenna, the voltage end, a high impedance end, is extremely sensitive to the surroundings. As I say, you put your hand very close to it, you'll hear the signals go down, and you'll hear the signals almost disappear if you grip it. If you touch the bottom of that antenna near the feed point, you'll find there's very little difference at all. The antenna is not sensitive at all. So for the same reason, when you attach something to an end-fed half-wave antenna, that loads the antenna and it reduces the frequency. What it means to say, in essence, is that the correct length of half-wave, the resonant length of the half-wave antenna, is no longer what you'd expect it to be. It's a bit shorter, which is great, because it means to say that if you're using it as a vertical antenna, it's not quite as long as you do expect it to be. Unfortunately, there's no simple formula. It's very much cut and try because it depends on the transformer and so forth. But there is this reduction in size. And so if you cut your wire to whatever the modelling length suggests, you'll find that it's actually resonant at a lower frequency than you expected. So bear that in mind. So let's go back to the dual band antenna. I use a trap which you may have seen in the previous video, but I'll show you again on the screen the antenna. Basically, you've got a vertical half wave for 17 meters, which again will not be as long as you expected it to be. Then you've got a trap, and then you've got the resonator section. Now I'll put up on the screen the lengths that I use, and the transformer that I use is a homemade transformer, which I also described in a video, and again I'll put a link to that video. So you'll have a link to the video showing you the transformer that you can wind very easily yourself, and also you can see the dimensions on screen of the wire that I ended up using. But as I say, because the antenna is so sensitive to anything attached to it, the transformer that you use may give a slightly different loading to the one that I use. Now the good thing about this is that both bands give you very low angle radiation, and that's good because it means to say you're going to work some DX, and you've got the optimum takeoff angle for working some good DX on both bands. And you've got a band, the second band, which is 17 meters, is a band which is quite interesting. Now you don't have to use 17 meters. You could use 15 meters if you want to put a trap in for 15 meters, so that your length of the first length of the antenna from the feed point to the trap is resonant on 15 meters. You've got a 15 meter trap which isolates the antenna on 15 meters, and then you've got a resonant section to tune it onto whatever band you want, which will probably be 20 meters. So it's a great dual band antenna. Now I'm going to show you the way that I have put this antenna together. A little bit Heath Robinson, but that's something, my trademark, I guess. I've got a tripod here, which you'll see, and I've inserted into that a fiberglass mast. I've used one of the spider poles and taken out the bottom sections, which are a bit thick, and it fits into the tripod, and that enables me to actually support the antenna. And the wire can either come down straight down the pole, or it can come slightly at an angle. I mount the transformer at ground level. That works quite happily, and then a bit of coax going into the transceiver. Do not forget to use your ferrite ring. I'll show you a picture here of the ferrite ring which I use. That tames the whole antenna, and it means to say that when you check your SWRs and resonance, you've got no problems. So always remember to put that ferrite core near the point at which the coax goes into the transceiver. The proof of the pudding, of course, is in the eating. And how does it work? Well, it works extremely well. I've used it when the weather's not so good. I've used the transceiver in the van, and when the weather's like this, I use the transceiver outside to get a bit of sunshine. The transceiver that I've currently been using is the new Discovery TX500, which is an excellent transceiver. Very slim. It's about ½ inch thick. It's quite amazing. Very good audio, very good receive audio, very good filtering, and some very good reports on the transmit audio. And these are all reports I haven't asked for, but the number of times people have commented on the quality of the audio. So all in all, very pleased. That runs 10 watts, and I've been able to work around Europe, into North Africa, and the odd contact, I have to confess at the moment, the odd contact into the USA has been on CW, but that's really bang conditions. So it works well. And I've already done the sort of advert for the Discovery. But I am enjoying using it. I've used the Elecraft KX2 on it as well, on this antenna, and I've also used the IC705, and of course, you know, the results are very similar. And because it's a resonance antenna, it doesn't need anything in the form of an antenna tuning unit, so you can just feed your transceiver into the matching transformer. And the other thing with end-fed half waves is they tend to be slightly broader bandwidth than when you feed it with a 50 ohm cable. Now you could argue that that's because there are losses in the transformer. And what are the losses in the transformer? Well, they're minimal. I've tried to measure it by looking at the current flowing into the antenna and so forth, and by doing A/B tests, and I would say that if there is any difference, it's no more than 1 dB. Now 1 dB on HF, generally speaking, is neither here nor there, because you've got QSB and the signal's going up and down like a yo-yo very often. So 1 dB, I can't be any more accurate than that. And here's the rather pleasant operating position. Microphone Morse key, TX500 transceiver, very compact, and works well. I've worked quite a few stations actually, and I think a lot of it is down to two things. So first of all, the antenna, which works extremely well, vertical half wave, dual band, 20 metres, 17 metres, which has been wide open today. Japan coming through, 5 and 9 plus.
Japan Hotel 8, radio Bravo Yankee, over.
And the audio quality on the transceiver seems to continually get very good reports.
Yeah, Roger, Roger, Golf 3, Oscar Juliet Victor, portable, very good afternoon. I'm also portable, call sign Sierra Alpha 6 Delta Alpha Zulu. Your signal, you're easy 59, but I am on the beach, right at the water's edge, 25 watts my end. Operator named Darren, back to you.
Okay, Darren, from Golf 3, Oscar Juliet Victor portable. Yeah, fine. Well, you're 5 and 9, bit of QSB, but you're 5 and 9.
Yeah, nice one, Peter. I take it you're running a 705, are you, or?
No, negative. I'm running the new Russian transceiver. I'm running the Discovery TX500, which is a very slim transceiver. You may not have seen it, but it's a very slim transceiver, about 1/2 inch thick HI, from Golf 3, Oscar Juliet Victor portable.
Roger, Roger. Peter, the audio is perfect. It's absolutely perfect. For 10 watts, 1,000 kilometers. That's extremely good setup you have there.
Which I'm happy with, and I guess customers will be just as happy as I am. Nice operating position. If only the weather was always like this. Golf figure 3, O Oscar J Juliet V Victor stroke portable. QSL?
Okay, thank you very much. Golf 3, Oscar Juliet Victor stroke portable. My QTH is near Zurich in Switzerland. The name is Peter, and I'm working with ICOM IC 7300.
Copy that, Peter, running just 10 watts to a vertical dipole from Golf 3, Oscar Juliet Victor stroke portable.
Golf 3, Oscar Juliet Victor portable. I congrats 10 watt to Zurich from London. Golf 3, Ocean Jet and Victor portable. Ocean Golf 4 Yankee Lima. Thank you, Peter. Nice report and nice QSO. The 73. 9 plus 5 depends on the QSB. And
You have a famous surname. Are you a parent of Roger Waters, or? Okay, I was joking, sorry. I think the pics of your QSA.com. Are you playing guitar or drums, over?
I play drums.
Okay, sorry for this. Thank you very much, Peter. All the best. 73, and thank you for calling me, and good yaxing.
To back to you, Jean, from Golf 3, Oscar Juliet Victor stroke portable.
Okay, Peter. Congratulations, Peter, for the 10 watt and report 59 plus. Very well copied, Peter.
So, as usual, thank you for watching this video. I don't often do one outside, actually. But it's a healthy option, isn't it? So thank you for watching this video. I hope it's been informative. And do try this antenna configuration. You can make your own traps, and again, I did a video showing you how you can make your own trap. It's very simple, and it's a great antenna. All you need is a decent transceiver linked to it.